Well, in the last video of this section, we're going to talk about even functions and odd functions. So let's define what an even function is. The function f is an even function if f of x is equal to f of negative x for all x in the domain of f. So let's see if we can figure out what that means. If we've got the x and y axis, let's go to this point A. Let's say the function value at A is that. So f of x, in other words, f of A is equal to f of negative A. So if I go to negative A, I get the same height. And if I go to maybe halfway to A and maybe the function is like that, that means this. And let's say f of 0 could be that. Well, basically, this is just one simple example of one even function. And what do we notice about this? An even function is, it's symmetric about what? About the y-axis. The y-axis acts kind of like the mirror, right? So if you were to fold this function over the y-axis, notice what would happen. This line would end up exactly on that. So it's a nice mirror image. And I could even do something like this if I wanted to. It's still a mirror image. This is the graph of an even function. So let's give some examples of even functions. Well, I'll do one because I already alluded to it. The absolute value of x. Before this looked like the absolute value of x before I added this curve and this curve. But what we're going to spend more time with on these is polynomial type of functions. So f of x equals x squared. X squared looks like this, very roughly speaking. Mirror image is the y-axis. And how about f of x equals x to the fourth power? Well, you may not have graphed this before, but it looks like x squared, only steeper. It gets taller faster, so it's going to look something like this. I should have made it maybe a little skinnier. F of x to the sixth would look like this, only steeper. So one example of even functions is just f of x to an even power, because x to the sixth would just get steeper, f of x to the eighth, and so on. And I'll make a note here. If every single term has an even exponent for x, it's an even function. That doesn't describe all even functions because f of x equals cosine x is an even function. Remember what that looks like? From the origin, it goes like this, or from x equals 0, and then it goes like that, and it goes on forever in both directions, but you can see it's a mirror image if you were to fold it over. Okay, that is an even function. Odd's a little tougher. This one's pretty easy. The function f is an odd function if I've got to throw one more negative sign on this. So I'm going to say f of x equals negative f of negative x. If I wanted to, I could have put the negative sign on this side, because if I multiply both sides by -1, this negative goes away and that puts a negative on this side. So an odd function is what they call symmetric about the origin, about one single point, the origin. So let's do some examples first. Let's do one f of x equals x cubed. x cubed looks something like this. Right? So if you were to take a right here, and you were to take negative a right here, notice that the height of a is equal to the height at the opposite of the height at negative a. So whatever this value is down here, it's negative. So just as one other generic example, if the height of f of 10 is 5, the height of f of negative 10 would be negative 5. They're opposites. Another example would be f of x equals x to the 5th. Actually, f of x equals x is a nice easy one. If you go over 2, it's got a height of 2. If you go to negative 2, it's the opposite of that, negative 2. And essentially, symmetric about the origin means if you go to 2 and negative 2, or 5 and negative 5, and 10 or 10 and negative 10, any positive negative pairs like that, if you take the f of 10 and f of negative 10 and draw a line through it, it's going to go through the origin. Just like this point connected to that point will take you through the origin. So that's what symmetric about the origin means. And then let's do one other example that's not a polynomial. F of x equals sine x. We already did that one once in an earlier video. Looks like this. It goes on forever in both directions. But basically, if you want to go back to folding it or how the symmetry works, let's look at this one. It's nice and easy. If you fold it over the y-axis and then fold it back down over the x-axis, this line here would be right on top of this one. Same here. If you flip it over the y-axis and then flip it and then fold it over the x-axis, these would be coincident. They would be right on top of each other. Same here. So again, that's symmetric about the origin. So one final statement before we look at some examples and try to determine if they're even or odd. If a polynomial function, if every single term has x to an odd power in it, then it is an odd function. All right, let's look at these examples. Without graphing them to look for symmetry, is this an even, odd, or neither? By the way, I didn't mention it, but certainly not all functions are even or odd. They don't have to be either one. So, what do we see about this? This is an even function. Every single term has an even exponent for x. Is that true? Even this one? Does this have an even exponent for x? Well, it doesn't seem to have x. What does that mean? That means it's x to the 0 power, because that's just equal to 1. So sure, even, even, even. And remember what that looks like? It looks something like this. It's a parabola where this point is 6. We'll get to this more very soon. But you can see my drawing's not great, but it is a mirror image about the y-axis. How about this guy? Well, it's got two terms in it. That's got an odd exponent. This has an odd exponent. It was a 1. So that's an odd function. C, even or odd, or neither. Neither, because we have an x squared, 2 is an even, and 1, x to the 1 is an odd. So this is neither. Last one, even or odd. Well, remember the constant term is like the constant times x to the 0. So We have an odd exponent and an even exponent, so that's neither. If there's a constant at the end, like this plus 6, it can only possibly be an even function. If you have a constant number at the end, plus 1, plus 2, plus 5, whatever, it is not going to be an odd function.